Anyway, let's have some quality 1 hour time. So today we have Dr. Ashish Kundu as a invited speaker for today's webinar. Dr. Kundu currently works for Cisco Research as its head of cybersecurity research. In the past, he has worked at Nuro as its head for cybersecurity and as a research staff member at IBM TJ Watson Research Center. He is an ACM Distinguished Member and has also been an ACM Distinguished Speaker. He has led security, privacy, compliance of self-driving cars, teleoperated driving, cloud-based healthcare, cloud-based AI-driven education program. He has more than 160 patents to his name, with more than 150 granted. That's actually a great record. And he has over 50 research papers. He has been honored with prestigious Master Inventor recognition multiple times by IBM Research. Dr. Kundu received his Ph.D. in cybersecurity from Purdue University and received the prestigious CERIAS Diamond Award for outstanding contribution to cybersecurity. Dr. Kundu is one of our classmates, the 1998 batch. And without further ado, let us welcome Dr. Kundu to give his talk on blockchain and the Vedas connection. Ashish, the floor is yours. Thank you.
Thank you so much, Ranjan, for a kind introduction. And then, of course, please call me Ashish. And I'd like to see there are some known folks here, especially Sandeep Mosa, and is here. And namaskar and to everyone. And I also saw Vishwanath and others there, I guess. But anyway, it's a great privilege for me to go back to Nitroa and give a talk. I hope it will not be a boring session, but what I'm going to talk about today is I'm going to share my screen right now. Let's see, give me a second. Yeah, okay. So I'm going to talk about blockchain and the Vedas connection. So I'll not dive deep into it. It will not be highly technical in terms of how blockchain works, etc. There'll be little bit of technicalities there, but the focus would be more about why blockchain, what is blockchain, why blockchain, and what is the connection that we discovered or we felt that there is a connection with our ancient Shastra and then the Vedas. So, okay. So if you look at essentially the blockchain, the cryptocurrency world, the DeFi, the decentralized applications world, if you're following that, you would be seeing, thousands of different startups, cryptocurrency startups, enterprise blockchain, Web3 companies all around. IBM was IBM was one of them, and of course there is Coinbase, if you know, is an exchange. Just to mention, of course, Bitcoin is one of the primary cryptocurrency, which is an application on top of the decentralized system that is enabled by blockchain. And there are so many of these. Are essentially some of the icons for those startups and organizations. Now, the key capability what is enabled by blockchain is decentralized trust. Okay, and then we'll go into decentralized computing, which is enabled by blockchain or similar technologies, and dive a little bit into the Bitcoin and cryptocurrencies, then some of the blockchain platforms and the Vedas connection, right? So let's talk about trust. So why do we need to talk about trust? Back in 1983, Ken Thompson talked about trusting trust in his Turing Award lecture. The question he posed is that, are you going to trust the statement of a program, or are you going to trust the people who wrote the software? Trust with respect to whether a program is free of Trojan horses. And this was an emerging lecture, of course, during our lecture by Ken Thompson, but it actually set the tone for the next decade, several decades till now, is how do we define trust? How do we implement trust? How do we enable trust in the socio-technical world? So to give an example, Log4j vulnerability that came up in 2021, and it was an open source vulnerability, right? It was part of Apache code, and that was used a lot everywhere, almost everywhere. Now the question is, who do you trust? Would you trust the open source code? Would you trust the developers there? Or would you trust the DevSecOps pipeline? Who would you trust, or who would you mistrust? We'll come back to, you can say, why are you talking about trust, right? So to pose that question, what is trust, right? Now, when Alice and Bob are talking to each other, Alice and Bob may represent two individuals, two entities in a system, any system, right? Does Alice trust Bob or vice versa? Or do they trust each other in a mutual manner, right? So if you look at trust, right, trust depends on the identity of the parties. Like you trust me, I'm giving a talk now and you're spending your 1 hour during your afternoon or morning time because you trust that something worthwhile would be is to listen from me, right? If you do not trust me, then you will not come and listen what I'm talking about. You will not even invite me, right? This is the for this specific talk, there's a trust associated with it. For any financial transaction, any transaction, there's a trust associated with it, and that trust depends on the identity and the attributes of the identity of the person, right? And the context of the transactions. Those are the different elements of trust. Now, however, that is identity relative. In Indian philosophy, I'll just take a brief digress into it. There is something called Aham Brahmasmi, right? That is non-transactional in nature. It's like, since you are the absolute, since I am the absolute, right? I'm not going to transact with anyone. There's no one else to transact with. Therefore, it is non-transactional in nature. That is like the highest level of identity and highest level of trust. Okay, so, but that is not what we're going to talk about. I'm just going to, for the sake of completeness in this scenario, I just want to mention that we have a notion of absolute identity, and therefore that is non-transactional in nature. But when you talk about relative identities, then we need to have established a notion of trust, and that is where you look at threat models, trust models, cryptographic assumptions, security systems. All of them resort into what are your trust assumptions, right? Who are your threats, and who do you trust? Okay. So if trust is relative, because identity is relative and the context of transactions is relative. Is there a question? Yeah, please feel free to interrupt me, and I love to have a more of an interactive session, because we all I'm part of the family here, right? so we can have an interaction there, and anyway, so Alice and Bob, right? If they are family colleague, they can have an interaction, they can have a transaction in a trusted manner. This trust is relative, right? So let's quickly switch to the context of computing, right? What is trust again? If you look at centralized computing, right? You have a client or a web browser, for example, right now, the Zoom application, and there's a cloud, there's a set of servers, right? In this case, there could be also a database, right? In a 3-tier application. So to give an example, there's a client, there's a database, there could be in a 3-tier application, there could be a client, there's an application server, there's a database, right? Now, in the case of centralized computing, again, there are multiple tiers. There could be multiple tiers, there could be, and then there's a browser, there's IoT devices, etc., right? So why are we calling this a centralized system? We're calling this centralized system because there is one authority that owns the entire application of this, owns in terms of authorization, who has the authority over this entire distributed application, right? That is the centralized authority. It is the authorities are not independent of each other in this case. Tier 1, tier 2, tier 3, everything, all those application logic, business logic, the data, perhaps, all of them are under the administrative power of a centralized authority. So the question comes, would you trust that centralized authority or the roles that are represented by the admin, privileged users, or roots of centralized systems? Would you trust that? Let me give an example. That given in this three-tier system, would you trust the centralized services? For example, let's say this is Google Maps, and Google Maps as a database, etc. Now, the browser or the Google Maps app on your device is telling you to take certain directions and giving you certain directions, take a left turn, right turn, etc. Now, why would you trust that? Would you trust it, such a service from another organization, right? Suppose someone, through an attack or through an insider attack, or maybe by mistake, the admin modifies the application code so that at certain geolocation, instead of asking someone to take a left turn, it asks to take a right turn, right? Who is going to, or the admin did modify the database also. The question is, who is overseeing that capability? Would you still trust that admin? Right, and that's the capability today. The admins can actually carry out insider attacks on the system, or the admin can be a victim of social engineering attacks and can lead to certain database modification. Maybe the admin's credentials are compromised, and that leads to compromise of the system. Right. So in this case, if such compromises happen, would you still trust the admin or privileged users or roots of the centralized system? Let me give another example. Suppose there is a grade list that is maintained by a centralized server in education IT systems, and that grade list is modified by someone from B to A, right? Will you how would you know? How would you know that such a change has been made and others are not aware of, right? So that is why there have been an evolution of trust over the time period. There was centralized trust, then there's distributed trust, because you can have hybrid cloud, and you can say, hey, my infrastructure is different for different regions, and therefore I'm going to provide distributed trust. That's why the GDPR and all the other data regulations are asking that our data will reside within our geopolitical region. Okay, that is distributed trust. Okay, that is in a way decentralized trust also, but because the application is distributed and still owned by the organization that manages the application, like Uber, right? They still own the eventual responsibility for that trust on Uber application, Uber systems, right? Even though there is a distributed trust, but then now, because everybody has capability to compute, have devices with them, everybody is part of the table. They can compute, they can provide their input, they can be part of a consensus, they can contribute towards whether they agree with trusting certain system or not trusting a system, agree with trusting whether a transaction is valid or not, agree with the agreement itself, or disagree with the agreement. That is democratization. So we are essentially evolving evolving towards a democratized notion of computing and democratized notion of trust. Right? And this is exactly where blockchain has come to a place. Right? Blockchain and Bitcoin represent the concept of an economic computing model. That economic computing model is essentially decentralized. The economy today is decentralized, right? Other than your centralized federal systems, right? You have economy mostly. Look at the stock market, highly decentralized. Almost everyone has a capability to play in the economy, right? uh, so, and that is why the evolution have come towards first started off with a financial use case. There's a cryptocurrency use case, right? So, and what are the different aspects of um, such a decentralized system, right? The decentralized system again has different layers. Right? We'll come to that, but there's an infrastructure layer, there's a network layer overall, network protocol layer, and then services layer, application layer, like everything else. However, in this case, if you look at the specific layers of network and protocol, right, that is where the changes occur, because this is where trust is determined across different untrusted systems. There are permissionless systems which is like public, like for example, Ethereum is a permissionless system, decentralized system. There are permissioned decentralized systems, which is like Hyperledger, and there are layer 0, layer 1, layer 2, different kind of systems are there. Right? Now, there are there are different algorithms, distributed algorithms, which are being put to work in these decentralized systems, and there are decentralized algorithms being developed to support how the untrusted parties can work together, can collaborate together, can have agreements together to carry out certain tasks. Yes, is there a question?
Can you show me your push-ups? Bye-bye.
Okay, I think maybe that's not a question. Okay, so I'll not go into that. Let's go back to more of a simpler representation of what is a blockchain. Right? So a blockchain has essentially, if you look at it, it's a party. It's a network consisting of many untrusted parties or semi-trusted parties. They are not part of any centralized authority. Okay, they have a ledger in each of them. Okay, and that ledger is append only, immutable ledger. Right now, okay, there are research going on towards making them unimmutable or mutable, and there are research also going on whether there should be only append only or some other semantics are being developed. Right? But we'll not go into that right now. So there are peers. Each peer has a ledger, is a distributed ledger or decentralized ledger, and they have sometimes they're always they're fully replicated. There are exceptions where they are partially replicated, and there is something called smart contract, or a chain code that runs a specific policy or a contract, which is called it's smart because it is encoded in a programming mechanism, so it can be enforced or processed per transaction or per a set of transactions in an automated manner, right? And then there is consensus management. You need to have consensus because there is no centralized authority to arbitrate and tell you whose execution of the transaction or the smart contract is the final one, right? So you need to have a consensus among all the parties on the network or some of the parties in the network, right? That's as simple as this. This is a simple replication or a description of a blockchain. Right? Now, if you want to talk about what else is included in a blockchain, we talked about a decentralized ledger. We talked about a smart contract, brief, in 1 or 2 lines. We talked about consensus, and that is where comes your consensus about proof of work. So proof of work is a protocol which allows multiple parties to agree in an objective manner, in a mathematical manner, saying that one of the parties did the work and that resulted in whatever was expected out of the transaction. Right? That is proof of work. And because it uses, the underlying principle is a cryptographic algorithm, a hash function, and because there are the ledger is protected using cryptographic algorithms like Merkle hash trees or digital signatures or hashes. That is why cryptocurrency came to the forefront as the name. But cryptocurrency need not be the only form of consensus and currencies, virtual currencies. Right, so there could be other different. So there's the essential entire world of tokenomics today. Now, smart contracts can be implemented using different types of languages. Almost every system uses existing languages. Very less number of them invent their own language. But for example, Solidity is a new language supported by Ethereum, and Golang is used a lot. Python is being used to some extent. Now, next is there are decentralized peers. Right? These decentralized peers, like for example, my MacBook. My MacBook can deploy a decentralized peer. What it means is it can run a smart contract. It can do certain type of mining and be part of the consensus protocol, and is independent from other parties, other peers on the network. However, one thing that is missing today, is slowly coming up, and one thing that we are doing at Cisco Research, that we want to develop a concept of economic computing. Without economy, these parties are not going to come to the table and talk to each other, right? So that is how do you incentivize the peers and users to make sure that the system is going to be stable, economically profitable in a way, or essentially there's the economy, there's some form of economy in play for carrying out consensus and executing smart contracts. Okay, so the economic model is something that is slowly evolving. Okay, I think given that I might have another 15 to 20 minutes, I will quickly go over some of the blockchain platforms. For example, some of them, Bitcoin, we know that came up in 2008. Satoshi Nakamoto, we don't know who that person is in real world. Is that a person? Is that another set of group, or it's something of an AI engine that generated the paper? We do not know. The Hyperledger Fabric is an open source system supported by IBM, and I was working on Hyperledger to some extent since last several years when I was there at IBM Research. And this is a permission system. Ethereum is a public blockchain, and it is essentially, you can say, the decentralized operating system. Then there are Hydrogen, Ripple, Algorand, Cardano, Solana, all of them. Especially Algorand is a startup which is trying to revolutionize finances around the world, and Cardano is developed by the same co-founders, some of the co-founders of Ethereum also. Solana, okay, I can go back to them. And again, Solana is another cryptocurrency system. Okay, now to understand how does a transaction get into the blockchain, right? The transaction gets in the blockchain in the following way. Just to give an overview of that, right? A peer, as I said, a peer is running on my MacBook, for example, a miner, and it sends a transaction to the system, and the block is a logical block could be created. There are proposers, then there are endorsers, there are committers, there are different layers, different types of peers today. And then certain blocks are not always added to the ledger. They are validated. If they're invalid, then they're thrown away. If the block represents a finalized transaction through the consensus, like proof of work or proof of stake, for example, or other consensus mechanisms like Byzantine fault tolerance (PBFT), then that transaction, that block representing one or more transactions, is added to the ledger. Okay, and once that block is added to the ledger, means everybody, all the peers who are part of the network, are going to update their decentralized ledger. Okay, and that the decentralized ledger state is updated everywhere to one state. Okay, and the transactions that were successful or successfully mined, there is an economic incentive that is given as a notion of token or a coin to those parties. There are miners who receive certain incentive. There are peers who take part in finalizing the transaction. They receive certain incentives, like gas fees in Ethereum. Okay, all right. I think I'm going to skip this one for now. So we let me pause here, and I'm going to skip, go into the another part that is the Vedas connection, right? But if you have any questions, you can feel free to interrupt me. That was saying that we just talked about what is trust and why trust is important, and the trust and the concept of trust is evolving over time from centralized trust to distributed trust to decentralized trust. Sorry, is there a question? Okay, and the decentralized trust led to the evolution of blockchain and Bitcoin and the cryptocurrency and decentralized apps, decentralized computing platforms.
Ashish,
Now,
question.
Sure.
What is the previous picture muted, so I spoke but you couldn't get it. What about the blockchain that our college is using for providing mark sheets? How is it relevant to this? Is this relevant to this one?
Okay.
Other one, yes.
I see. So I'm not aware of that track, but of course it makes sense. I hope they're implementing it in the right way. Again, the way why we should use blockchain is because there are untrusted parties who want to collaborate with each other to come up with a more a high value output at the end of it. That's the idea, overall idea. So anytime we want to use a blockchain, we should keep that in mind, that there are untrusted parties who want to develop a stronger notion of trust for a certain type of transaction. Right? So in this context, if you want to have, as Sandeep sir said, right, the NIT Rourkela it seems it is using blockchain for mark sheets. So it is maybe because it want to do an auditable mechanism of the grades, right? So essentially, if you want to go back and say, how did I get a B when I was reserving, or I think I would get an A, right? Then you can look at different parties and where that change happened. So that's a great point. As I mentioned about the mark sheet thing, I think in the examples, right? If the centralized server the admin is authorized to actually has the authority, not authorized, has the authority that it can go and modify the database, changing somebody's grade from B to A or A to B, right? And there's no one to audit them. It's very hard to audit it unless you look at logs and analyze them. In this case, I think they are trying to avoid that. If I am correct, so the professor or the teaching assistant or the lecturer, whoever is grading the exam sheets, they will provide certain grade that will then immediately go to blockchain and get recorded there. And then when that set of mark sheets, set of exam papers of a group goes to the registrar or the next person in the pipeline, they will then try to then put those marks into the system, and then the smart contract can verify whether the marks that are already entered by the person who is evaluating the grades, evaluating the answer sheets, match. That is one part. The second part could be that if there's a mismatch, then that will notify everybody or at least some parties to say why is there a mismatch, so they can reevaluate it before it becomes a final mark sheet and the student complains or a student is happy he got an A instead of a B, the expected, right? So I think that there are two things. One is putting in checks and balances. The second one is auditability of the mark sheets in place, and the third one is at the end you can actually generate a transcript in an authorized manner much more easily than today we are having paper transcripts. That could be forged if needed, but if a mark sheet with a blockchain signature, it will be hard to forge because of the untrusted decentralized parties signing it. Does that answer your question?
I have a follow-up question. The follow-up question is now
here.
that the mark sheet is authenticated and posted on the web. Now, what do we do with the universities that have not accepted this system yet? Do you know what they're doing, or you are expecting it to happen in next 1 or 2 years?
No, so accepting such systems require many things. Of course, there should be trust on the system itself, like who implemented those systems, whether this is being implemented on a permission system blockchain or a permissionless blockchain, what kind of cryptographic algorithms are being used, who developed them. Essentially, you need to have trust on the code itself. And therefore, the first question comes like Ken Thompson's talk on trusting trust. Who do you trust? You have to trust the developers as well as you have to trust the libraries. So cryptography libraries you use. For example, in US, if you are FERPA, the FERPA is one of the primary FERPA is a compliance requirement, and that requires FIPS 140-2 vetted cryptographic libraries to be used. Now, I don't know whether in India that's kind of a capability there. We actually, I'm involved in other kind of cryptographic processes for Indian government right now to support them in some extent, but to help develop those scenarios, but not for blockchain. So if such standards are there, compliance requirements are being met, and there's trust being built around those networks, then it should be acceptable. But if it is being developed by people in, for example, the countries would not trust or teams from there, then it'll be hard for adoption.
Ashish, I think the question from Sandeep Babu was if NITR issues actually certificates of blockchain, and if there are no universities in the US who accept that, then there's a problem. I think that was the question, I believe.
I see. Yeah. Actually, thank you, Sarath sir, for mentioning that. I got that also, that part of the question. I think they can accept that mark sheet. May not be in a digital manner, or a digitally verifiable manner, but still they can say, because they are currently accepting paper based transcripts, right? And if they can accept paper-based transcripts, that is easy to forge, in some way. Okay, and therefore, I don't know why they would not accept a mark sheet from a blockchain. If the public key certificates the of NIT Rourkela is valid and that has been imprinted properly as part of the certificate, and that can be verified, then that should not be any problem. But yes, there is more bureaucratic work to be done to enable that trust.
Let's come to the
Sure,
end.
yeah.
We'll have some additional questions. Okay.
Sure. Yeah. I think there is one question from Chinmay, but maybe Chinmay, did you have a question?
Yes. Yes. Can you hear me?
I can hear you now. Hello?
Okay. No, I think I was about to ask what are the challenges in adopting blockchain. And I think you covered it in that example, basically, why this transcript is not, may not be acceptable at other places until they have a trust or like thing, right? So
Yeah.
you can continue. So we can.
Okay. Yeah. Thanks.
Yeah.
And thank you, sir and Sandeep sir. All right. So I'm going to quickly then go on to the Vedas connection, which is the more exciting part, And so the interesting story here is that my friend Arun Ayachitla, who was a distinguished engineer at IBM Research in New York, and we were colleagues, and his wife Nagamani Mani, we were having coffee together at their place in an evening, and they are actually they know the Vedas very well. I do not know much of the Vedas, to be honest. I don't know anything, in fact, in that scenario. And we were chatting about how the Vedas, even earlier also, we were chatting about how the Vedas are maintained as Shrutis and everything, right? And as we discussed, we figured out that there's a decentralized aspect to the Vedas, how it is maintained, how the integrity of the Vedas is maintained, because it is for more than thousands of years, or more than 10,000 years, or even we do not know for how many years it is there, and it's all transmitted like Shruti through recitals, right? Still, we are able to maintain not only the text of the Vedas, the shlokas, but also the pronunciation appropriately. Which is one another aspect other than blockchain, that we should be able to maintain the authenticity and integrity of the pronunciations as well. Okay, so that is where the decentralized capability comes in, and it was understood that there will be corruptions that will come into this system, the way we remember the shlokas and transfer them, their semantics as well as their recital, right? It was collaborative, right? There is no centralized authority. There is no centralized authority who maintains the Vedas, right? There is no copyright owner as per se who will maintain it, and it's transmitted as Shruti, different than Smriti, and there are also shlokas and padas which have been added to the Vedas time to time. Of course, not that frequently, but time to time. There were first Samhitas, 89,000 padas, and is perhaps the oldest ancient literature in the world, if we call that as a literature. Yes, it is a literature in some way also. And this is not, I'm not saying that. This is, in fact, Scharfe has mentioned that Western researchers have talked about it. So there are some references here. So since there is no centralized authority, the Vedas can be compromised to inject errors, to the shlokas. Like instead of saying, I'll come to that. They can compromise pronunciation. They can compromise semantics. How do you preserve the correctness and integrity of each of them, the syntax, semantics, and phonetics? And you can still carry out collaborative updates. This is a challenging problem. Right? So what they do is that they have essentially 8 different. So what they do is that they encode they take a shloka. Okay, aham gacchami. If you understand Sanskrit, aham gacchami, right? Or aham apanam gacchami. Apana is shop. I am going to a shop, right? Aham apanam gacchami. This is not a shloka, but I'm just trying to use my highly limited Sanskrit knowledge to give you one sentence and try to see that. Right? So this aham apanam gacchami sentence will be encoded with different patterns, so that if there is a modification to aham apanam gacchami, like if you say aham apanam gacchasi, which is incorrect syntactically, but gacchasi, then that can be, in this case, if you just put it that way, aham apanam gacchasi, you are just modifying one word. But if you put it in an encoded pattern, then you are able to modify it in many places. So the hardness of carrying out a tempering attack, integrity attack on the shlokas on this sentence increases. Okay, and there are, on top of that, there are 8 different such patterns. Okay, so you have to modify. If you are able to compromise one pattern, right, successfully, you may not be able to compromise all the other patterns, right? So therefore, as an attacker, this compromise will be detected, right? Now they will come together and have a conference sometime to other and say, hey, this is incorrect. Right? In fact, now the second one comes with the pronunciation. The pronunciation has to be poetic in the proper way of Sanskrit pronunciation. So therefore, through the pronunciation, they can also determine something is wrong. Okay. So there are 8 different types of patterns, which are called pathas. These patterns, the encoding pattern is called pathas. And they are jata, mala, sikha, rekha, dhwaja, danda, ratha, and ghana. Okay. My friend Arun and his family, they essentially are ghana pathis. They are responsible for representing and protecting and reciting the Vedas using the ghana patha, the last patha that is there here. Similarly, there are 8 different communities. Each of them is responsible for one pattern. They will recite the Vedas. They will, if they have to update, add a shloka to the Vedas, or if they have to do anything with the Vedas, they are the representative group for that patha. I think there are Odiyas whose last name is Ratha. I'm not sure, but perhaps they are responsible for the Ratha patha. I'm not sure, but I'm just there's a guess I'm making. Which I can perhaps talk to some of the Rathas if we have, and perhaps figure that out, right? So there are, each, and they're complicated. The encodings are so mathematically intriguing that they actually encode it pretty well. So let me give an example, right? So in this example on the right hand side, if you modify and add an error there, it will be easy to one that society can find out that, right? So if you take 1, 2, 3, 4, 5, 6, 7, 8, 9, the rekha patha, it will encode it the following, right? This is just one line, It will, of course, increases the memory requirement of of the entire shloka, of course. But then that is how it is. If you anytime add a CRC code or a hash or a cryptographic digital signature, you are increasing the size of the system. But then they are not as sophisticated for error detection and error correction like these pathas are. So we need to, blockchain community need to learn. Perhaps we'll learn from this as well. I'll give an example of what they have learned already. May not be from here, but I've been talking about this since 2018. So maybe they're inspired by that. I don't know. So it goes like 1, 2, 2, 1, 1, 2. Right? They take the first 2 terms, 1, 2, like 1, 2, 2, 1, 1, 2. Then they'll take the from I2 to I3, right? Or I4. They'll take 2, 3, 4. Then they'll switch it on 4, 3, 2, 2, 3. Similarly, they'll result. Suppose you want to modify, you want to add a 10 after 9, right? After 9, you want to add 10. How many changes you need to do? you need to carry out changes starting with the last part of this triangle. If you look at this kind of a triangle, of the matrix, you have to modify everywhere here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then we'll be adding another one. So essentially, for one insertion of a term in an incorrect manner, or if you want to add a term, you have to modify about 12 places and also modify the entire recital. Right? That is going to raise the flag to the people who are reciting it for ages. Right? So that's the idea, and they can then correct it back because they have the pattern. There is error correcting also. They can correct it back, right? Which is very powerful. The fact that we as a community, as a society, we figured out this decentralized nature that is necessary to protect the integrity of our Vedas, of our literature, of our work, and we figured out that how do you encode them, is pretty powerful. Shows the advancement we have had over the time. So since that time, similarly, the Ghanapatha, right? I think I'm not going to go into that, but this is like another different pattern you can say. So as I said, right, there are periodic consensus that also is carried out to determine whether there are compromises by one society. Maybe one society is compromised, they're propagating. One community propagating that. So they determine in a consensus-driven manner among all of them. So there are multiple chains, multi-hierarchy. One of the things that current blockchain platforms are taking multi-chain principle. Okay, they're also taking up multiple hashes also, and they can also allow adding new stanzas based on trust, based on consensus, saying that okay, these are the shlokas that we can add to the Vedas. Now, so okay, essentially the concept is developing or had been developed, the concept of decentralized social groups, and that is what is engaging in the concept of Mastodon, right? If you know, Mastodon is a parallel social network like Twitter, but it is a federated one, and they are using the concept of federated social groups where there's a network of networks, and but in this case, in the Vedas case, they're just focusing on encoding or patha used for the society, and for the Vedas case, there's a consensus of policies that are basically signed in a Shruti manner. The signature is by these Ganapathis, different communities supporting the pathas. They agreeing on that, as well as they're signed in the phonetics manner. The phonetics is your signature, where you figure out something is wrong or not in the way you pronounce and recite the shlokas. Okay. So to give an example, right? Hashing in the current blockchain world, you use hashing, which is similar to the pathas. Multiple hashing schemes is something that is there in multiple patterns are there in the Vedas. Current blockchain schemes are using only one hashing schemes, but the future is looking towards using multiple hashing schemes in case one hashing schemes is broken. For example, MD5, if you are using MD5 is broken. SHA-1 is also broken to some extent. So you can got into another one, right? And post-quantum cryptography also comes in. Of course, they do not affect hashing schemes, but they affect public key signatures, and therefore the multiple hashing schemes can also incorporate post-quantum safe cryptography. So essentially, there are multiple things we can learn from the Vedas, the way it is using decentralized mechanisms for protecting itself, and the future blockchain platforms can also learn from it using multiple hashing schemes, multiple and safe cryptographic signatures, and also it could be error correcting as well in some way. Some of my papers actually work on error correction on digital signatures to some extent, but then it could also learn from multi-chain systems or network of networks that is already there. Okay, So to give a quick summary of what we talked about, we talked about first part of the talk, and we focused on what is blockchain, what is trust, and how trust is evolving from being centralized to decentralized. And that is essentially empowering the development of decentralized platforms. That way, there are 15,000 plus cryptocurrencies. Now, then we moved on to the next one is decentralized trust, and how the similar process was used by the Vedas, right? And therefore, perhaps we can take to the formulation of new blockchain platforms is multiple hashing schemes. The other one is error correcting schemes I have not mentioned here, and perhaps a network of networks or multi-chain schemes, which is already in play. Okay, let me pause here and see if there are any questions. I'm available beyond the hour also, so we can go beyond, go beyond 5 minutes as well, as much as we want.
Yeah.
Thank you so much.
Yeah, thank you, Ashish. And fascinating. The connection with the Vedas is very fascinating. Yeah. I'm sure there will be a lot of questions. So let's see if the attendees have questions, and we can take one by one.
I have a question. This is Sarat Mohapatra. I have a bunch of questions, but let me start with the Vedas. Vedas have been corrupted. The reason I'm saying this is you might know about Aswamedha Yajna. And when Vedas were taken by the Britishers, and Sanskrit language is a very complicated language. A little bit of change can actually make a big difference. And that is how the Britishers, they also took one of the Indians, name is Jha, I think. And so making a little change, they made certain portions of that more vulgar. So that is what I'm saying, that, things, this is a much bigger task. And so it can actually, unless there is you go back to 10,000 years or something when the Vedas were done. So we may actually get the current version might have more corruption in the Vedas.
That's a great point, sir. I actually am not, as I said in the beginning, I'm not an expert, or I do not know much about the Vedas. My co-authors were aware of the Vedas, so perhaps we can discuss offline on how where it is corrupt, and we figure out how their corruption happened, how they could avoid the decentralized trust mechanism that is in place to compromise the Vedas. Would love to see. Maybe that will be a interesting discussion. We are actually starting up a new working group, technical working group, on how the Vedas and the Sanatana Dharma or Indian work can help technology in many ways. Or what is the connection there? We are trying to build that group with different professors in US, and maybe we'll have some people across India and other places. But we can take that offline. Thank you.
Yeah, I think that's fine. I think let me ask you one more question, then I'll sit down and listen to others. You mentioned about the node. And if at all you have a transaction, does it go to one node for the transaction, or it goes to distribute to many nodes?
Great point. So the transaction goes to different nodes, but initially you can submit. You can basically submit it to one node. Either you are the if you are a submitter, and if you are a miner by itself, you submit to the entire blockchain network that is broadcast to everybody. Then everybody picks up, or you submit it to, let's say, your organization's miner or peer. You submit it to that then broadcasts it to the network, because there is no centralized server. So everybody then picks up and they start validating, on the transaction. If it is a proof of stake, not everybody is involved in validating the transaction. Only some of them are validating the transaction. So there's a validation pipeline that's being built up on to reduce the cost of validation. But yes, so it can be. Sometimes most of the times goes to all the people, or many of the peers or all the peers, and that's why they finalize the transaction.
Okay. Let me wait for other questions. Thank you.
Maybe I can take the opportunity for a question. So Ashish, I mean, when we look at blockchain, and I understand how the decentralized system can help, but is there any role of government? Can government play a role, or government should play a role in blockchain? Because at this point in a conventional trust system, you have government playing a role in creating trust, whether it is in the form of law and order, agreements, those kind of things, right? So what's your thought? Do you think that government should play a role? And if so, in what ways? Yeah.
So it depends on the use case and application of the blockchain. As I said, the government should develop certain compliance, regulatory compliance, and other requirements or other policies around blockchain. That's called responsible digital decentralized intelligence. For example, you see Berkeley has a center called Responsible Decentralized Intelligence. You have to be responsible the way you engage in a blockchain platform, right? However, the government should not engage in all blockchain platforms. They cannot, because if it's an enterprise blockchain network, right, then the enterprise is essentially governing that in a decentralized manner. All BUs in that enterprise will be part of that. Government doesn't have a role to play, but they should adhere to the compliance requirements of the enterprise level requirements by the government that is there, right? The government should be part of or should manage the trust aspects of financial blockchain, especially cryptocurrency, where the currency is being used not as a token for your Best Buy rewards, okay, but they are used across different countries, across different banks, etc. Right? Otherwise, there will be black money and money laundering that is going to happen. That is happening today in the cryptocurrency platforms. So therefore, that is where the government has to come in. There are other problems, something called front running. Front running is prohibited by SEC in real world stock markets, but front running in cryptocurrency world, blockchain world is like everywhere. Okay, and that needs to be stopped as well. That's a very hard problem to solve.
Okay, thank you.
Thank you.
Any
Any
more
other
questions?
questions?
If there is no other question, I have actually a couple of questions. This is Sarat.
Sure.
I'm going back to the question that Sandeep Babu started. NITR has started giving certificates through blockchain. And in fact, they're saying that we are following the IIT Kanpur model. I think IIT Kanpur does that. Now, the problem we have actually a number of issues with the transcript, how the students can get transcript when they're trying to go for higher studies. And we have been struggling with NITR for almost a year. And so the question is, many of the universities in US, at least, they need physical certificates that NITR has to send that to the past student and in a sealed envelope. But many of the universities in the US don't have that concept of the blockchain. I'm not saying it's not practical, but they don't have a program to make it happen. There are probably few universities who are actually giving in US blockchain certificates because they are the ones who are teaching blockchain. And therefore, they think that they can actually use that but they are actually not really known universities that the students like to go to. And so my question is, the universities have to have a process to accept blockchain certificates. If they don't have, how to do it?
Okay. So yeah, I completely agree with you that first of all, the universities should be ready to accept the US universities. If we say should be ready to accept digital certificates, digital transcripts. Okay, that's the first thing. If they are not accepting digital transcripts, then even whether they accept a blockchain-based transcript or not, that's not going to work out. A digital transcript could be like a digital, digital driver license, okay? and that is being in play. In fact, in US, the digitalization of the systems are much more, a bit more advanced than other parts. Maybe in India also, but in India they're actually catching up. Sometimes they're ahead of other places as well. In US also. So I think it is again, if you look at a university, they have their own bureaucratic processes. They have a process that need to approve acceptance of certain transcripts. They have to have that mechanism in place. They have to build those technology and those applications so that that can directly operate with the NIT or IIT Kanpur blockchain to retrieve those transcripts, right? And that transaction, there could be certain cost involved with that. Right now, if you look at the big cost of it, the student is responsible for bearing the cost and sending it to them, and they just the recruitment committee looks at them, opens the package up, and looks at them, the transcripts, right? But when you involve a blockchain, then there has to be a client on the side of the university who will interact with the blockchain by NIT Rourkela or IIT Kanpur and request the transcripts, or if a QR code is provided to them, for example, that QR code can then go back to, they can take that QR code and give it to the blockchain platform to validate it, right?
Yes.
These transactions incur gas fees or money in some way, currencies, right? Who is going to pay for that, right? So the students have to incur that. So there is an economic play, as I mentioned in the beginning, and in the middle of my talk, there's an economic play that has to be taken care of. The second one is, how would you trust whether this blockchain has not been compromised? Is it really implemented? The ledgers are using the right kind of cryptography. Okay. To give an example, how would you trust the implementation of the blockchain network? So that is where, as Ranjan pointed out, the government's play have to come up. Okay. And they have to have perhaps the government or the institutes have to sign up an MOU, or sorry, not an MOU, sign up an agreement with all these universities to have that set up. There is an upfront cost, changes to processes, changes to the way they trust certain cryptographic libraries or not. Certain countries have to be in place.
Yeah, I think
so therefore, to enable that, just to complete the thought, sir, is that they have to be backward compatible also. So therefore, we cannot jump to the totally decentralized world right away. We have to have a kind of fiat currency, and we have to have a fiat mechanism of sending transcripts to the university.
Yeah, I agree with you. I think the problem is the universities also should have the infrastructure.
Yes.
To make it happen. And if they don't have, then things are going to be, I think students may not really mind paying the additional cost, which they are right now. And I think the infrastructure is not existing. And so that needs to be done.
Yeah. And skill sets.
I'm sorry. Yes.
And skill sets.
Yeah, that's right. Yes. And the another question I have is the open source. How do you, in the open source software, for example, anybody can make modifications, and how do you protect?
Okay, how to protect your system when it is using the open source software?
Right.
So this is something I've been working on for several years now. In fact, I'm on the first. We developed few techniques, etc. But the challenge goes back to, how do you determine the supply chain of your software? So like, for example, you look at your food and you want to determine, like in India, in Odisha, for example, where I'm from, I remember my father will go and ensure that the food that is coming from, the vegetables that are coming from, are from the right people. They are using the right kind of fertilizers. They will not bring in like a chemical fertilizer based food. They'll bring in only organic. That time.
Yes.
So you need to know that supply chain of what is going into building that system. So for the software, you need to know what libraries, where did you get the library from? Even if it is a Google library, for example, a JavaScript library, what did you download it from? When you downloaded it, did you verify its integrity? Did you download it through a secure network? Okay, saying is that using public Wi-Fi, in not in a security aware manner, is like using allowing yourself to be infected with viruses, etc. And that's easy to do. Okay, and there are a lot of blogs, etc. I will not go into the question is open source. In today's world, you need to have an analysis of software supply chain, and therefore you need to have this bill of materials BOM. In fact, we are using we are building a system around that, actually, a more cutting edge system using advanced cryptography right now in my group. And there are many. There are SBOMs, there are Git bombs, there are different kinds of standards are already in place. But then they don't solve the entire problem of open source bugs or vulnerabilities, providing you a path into an attack path into your code. That's a difficult problem, but I hope we'll be able to solve. We'll be able to address it in a reasonable manner in some way.
Yeah, you talked about admins. Who is actually the big boss? I mean, admins can modify it, but the modification has to be recorded, and then I don't know really if there's a chain of command. I think somebody say, yes, it has gone to this point and everything should be perfect. Is there anything like that?
Where in open source or
anything actually?
Anything.
Because, yeah.
Yes, so that is where comes in the concept of separation of duties. That you don't, there is not on one person, one individual, one entity to decide upon highly expensive or highly valuable systems and transactions, right? Like in a banking system, right? You have separation of duties. So similarly, you need to have a decentralized set of decision making for such decisions. Even look at SolarWinds attack, right? So SolarWinds attack that happened a couple of years back incorporated a DevOps mechanism being compromised, and the developer account that was compromised that resulted in injecting a malware, or malicious code or malware into their chain. But it is a developer that they know, so they validated it, and the code was pushed into production, right? Now, in that context, there is no checks and balances in place. So you need to have separation of duties. You need to have those things authorized by other people as well. But then, since code is complicated, you cannot have an individual manual look at the code. So you need to have code analysis, security analysis of the code, all in place in parallel. And blockchain plays a role. In fact, we are using we are actually developing a decentralized software supply chain security platform, Cisco Research.
Ashish, thank you from my side. It's a wonderful talk, and I appreciate that. Okay, go ahead. I'm done.
Thank you so much, Sarat sir. It was great interacting with you. Thank you so much for great questions.
Sandeep Mosa. You are on mute.
No, I am done. I wanted to know the blockchain use by NIT Rourkela, and I think the follow-up question was made by Sarat Babu. So I'm okay.
Thank you.
Thank you so much, Sandeep sir. So I would like that if they need any help or in terms of anything, we can perhaps discuss that. I'll be happy to help or bring out other people into the play if needed to adopt for adoption of the mark sheets from NIT Rourkela. Try to figure out a way to do that or help in whatever way.
Well, thank you.
Any more questions?
The only thing, Sanjan, is does he have any email address we can send the questions to him?
I think he said his email address.
Okay, thank you. That's all.
It's recorded, right? It's being recorded, right? So Ranjan,
Yes,
if you can remove this part in a way, I don't want to publicly put my email address,
we'll
my personal email address. Yeah, thank you.
Understood. Yeah. So one more question,
And,
Ashish. Good.
Sorry, and we can discuss about the before we publicize the video. I like to take out few things about Starbucks, etc. Just it should be in between us. Yeah, I don't want to offend anyone.
Hello, can I ask a question?
Sure, please.
My question is, you said you're not expert in Vedas, but you gave 9 pathas, I guess. And your friend is a part of the Ghana patha, right?
Yeah.
And you mentioned something about there is a Ratha patha, which the last name Ratha, they may be able to recite it. This is hereditary part you're talking, or what is it? You understand my question?
So, got it. So the community is not just, there is a hereditary aspect to it, but I need to do more studies into that.
Okay,
I haven't gotten a time to, but there's a community. So it's like Ghanapati. So they need not belong to only one family. As I understand it, if I'm correct, they belong to, let's say, some communities, but the Ghanapatis are essentially like saying all cryptographic researchers are a community.
I see. I was listening to yesterday, somebody sent me a WhatsApp recital about numbers, okay? Number 11, 12, 13, 14, 15, all that stuff. And it's such a beautiful sloka. And it tells you exactly what is the next number going to be by reciting the sloka. I don't remember exactly, but, so like, for example, 6 times 6 is 36. And the sloka starts with adding 13 to it and becomes 49. 49 is a square of 7. Okay.
I see.
The next sequence, next sloka starts with a 49 and adds 15 to it. It becomes 64, which is square of 8. So 7, 8. So it goes like starts with a 2 to 3, 4, 5, and how the sequences happen with the sloka itself. So you don't have to memorize all that. If you know the sloka, then you can detect all the answers.
Yeah.
So it is, I won't believe before I read this, before I heard you, because Vedas have all the answers. We don't need to go anywhere else.
Hare Krishna, there is a book. There's a book called Vedic Mathematics, and
I think I have that. Yeah,
and it has actually aphorisms. I think it's called aphorisms. It's a very short, and it solves a lot of mathematical problems. But anyway, because you talked about Vedic mathematics, I just. But
I agree.
Yeah,
in fact,
somebody sent me that sloka on WhatsApp yesterday. So,
in fact, there could be a connection of the Vedic mathematics with the different pathas and the way they're encoded. Also, I don't know.
I see. Okay.
Okay. I mean, it's a
question from.
It's interesting. We got 10,000-year-old scripts, which has all the answers. Okay, and we're still researching. That's what is going on right nowadays.
One thing I learned today is both Smriti and Smruti
Shruti, yeah.
sources of error.
No, Shruti and
Yeah.
Smriti is two different things.
Huh?
Shruti and Smriti are two different things. Yeah.
Different things.
Both are different and both are sources of error, because what you
Exactly.
what you hear,
I think, yeah, exactly. There are errors. Yeah.
Yeah,
Thank you. I think Virendra sir has some questions.
yeah,
Please go ahead.
I don't have a question, but I just wanted to make a comment on these Vedas. I mean, how they have taken care of that there is no corruption takes place while it is being transmitted from one person to another. I would like to add the way we pronounce. I mean, you must have noticed that the way people pronounce Sanskrit in Odisha is quite different than they pronounce in Varanasi or in the south. But they still, with this, I mean, when you pronounce it differently, it could mean a different meaning. But they still have kept that. The meaning still stays, whether you pronounce Vedas in Odisha or Varanasi. The meaning still stays the same way. That is kind of amazing to me.
Absolutely. But if we compare the relative distance or difference in the pronunciation from one region in India to another region, between Odisha and the South India, for example, is there, but it's much less than when an American person who has not practiced Sanskrit pronunciation earlier, the distance will be higher. And the way you take one term and pronounce it, they might want to divide them up,
Right.
and that changes the semantic, that changes the meanings to some extent also. So perhaps we do not do that. That's why we still have the same meaning, but perhaps we may not have the same meaning. So we need to have a greater level of pronunciation and also understanding of the language to do that in a right way.
And I wanted to make another comment about Saurabh Babu. He said the Sanskrit has been corrupted by the Westerners, but that has not actually gone back to India. I mean, people who they still deal with these slokas, I do not think they are affected by that. That's my comment.
Yeah, I don't know, Birdavu, but I have, especially the vulgarity that came because of a little bit of slight change. I'm not sure whether it come back to India, but it was published by one of the Indian scholars. So that's
but then is it incorporated in the by the Vedic scholars? Is it accepted?
Yes.
Yeah.
I don't know that. I don't know that. Yeah.
actually, I recently came to know something interesting. I was in India. I read a book by a professor of Sanskrit of Calcutta University. And she says the name of the book is Gita Ki. I saw it with Swadhin Patnaik has the book. And I was reading there when I was with him. So it says 2-3 things. One is that the number of slokas, this of course is also corroborated by Ramakrishna Mission's Gita, that number of slokas in various versions is different. 729 in one, something else in another. So they have come and gone. The other thing is that the timing now they have come of writing of Gita is the Kusan dynasty. Okay, Kusan dynasty is about 100 to 50 something to 200 BC AD. So not 5,000 years old. So lot of things are kind of mixed up, and still not age is not fixed, and still there are debates on it. We will all, particularly with the Hindutva wave, we say 5,000 years old Indian civilization. But there are various versions of it. So there are debates going on. And if Gita is, 2,000 years old, how does it get included in Mahabharata.
It's always a debate on that. So.
Anyway, I don't want to prolong the discussion. So let us, I will leave it at that.
Yeah.
Thank you. Thank you so much.
Either way, Ashish, it was a great talk. Thank you.
Yeah, it was
Thank
really.
you so much.
Yeah, it was really a great talk. Thank you, Ashish. And I know it's Saturday. It's not a preferred time for a lot of us. Thank you, and thanks for all the attendees. And I'm sure we'll discuss this because there is a lot of unanswered question, because I think the Vedic connection is pretty interesting. I do see there are a lot of things even in material science that we do has some connections. Okay, I think there is a lot of anecdotes, for example, and sometimes people take they take advantage of those things. Yeah. But I do think that what has been developed in the past is profound if you really take the uncontaminated stuff. So I think that's an area that we'll have to continue debating. But I truly appreciate you spending the time and giving the talk. Thank you very much.
Thank you.
No, thank you. Thank you so much for inviting me and listening to the talk. And I hope I'll be this talk, this work is going to energize in some way, open the box of how the Vedas and how our thousands of years of work, culture, can be connected to the advancement of technology. As you said, Ranjan, right? There are many things that we connected, and Sarath sir, Virendra sir, and Sandeep sir. Thank you so much for the questions and great thoughts. We'd love to have maybe another session, a brainstorming session, not on this talk, but just on this topic.
Sure.
Sure.
Thank you. Thank you.
Thank you.
Okay. Thank you. Thanks, everyone.
Thank you, Ashish. Bye.
Thank you. Bye-bye.
Bye.